Welcome. And I'm Frederick. I don't have an introduction slide. So my background is first in computer science, then in graphic design. I did a master's in graphic design in Belgium. I am from Belgium. And then I started doing research on basically democratizing first computer tech for artists. And then now in the latest research, we're doing this specifically for AI. So that's my background. I'm also working privately more towards data visualization for mostly media companies. And then I'm also a coach at LAbO, which I'm gonna talk extensively about because this project came out of LAbO. And then I'm also gonna make some advertising for LAbO so you can all join. And so, yeah, this is the project that I want to talk about, and it's called Sensuality. And it's a project created during the LAbO Summer School in August of last year. That's a bunch of international students. So there are graphic design students, there's philosophy students, advanced master students, musicians, and they're all coming together. And I'll talk a little bit more about the platform itself. And then the algorithmic gaze that I mentioned here is the research project that I'm doing around this democratization of AI, but also understanding a little bit the problems with AI, or let's say the way that AI looks at us, and sort of try to understand how it looks at us versus how we look at AI, and then the links between the two. I first want to talk a little bit, so that the talk's a little bit structured in this way. I first want to talk about LAbO, what that is, and why that's the great place to come, where this project could come from. Then I want to talk about the project itself, so the Sensuality project, and then I also want to talk a little bit about the algorithmic gaze, the research project that I'm doing. So first off, I want to talk a little bit about LAbO. So LAbO is a summer school. It's for people who recently graduated from a master's program. Sometimes people in their last year or after their last bachelor join, but it's mostly master's students. And it's held every year in Antwerp in the Singel, which is an art center for music and dance. The important thing about LAbO is that it's interdisciplinary. So it combines graphic designers, photographers, composers, musicians, even circus artists. They all come together and they make art. So it's a 10-day program. We had 45 participants. It's in real life. Lucy also did an episode of that, which was in full COVID times, and it was online. But last year we could actually do it in real life. There's always about 8 coaches. We do a bunch of workshops and lectures. And then there's a big show on Sunday where actually people get to see the work. We invite people from before. This is the episode from 2019. So you can see everybody was happy unmasked. And yeah, and so close together. Yeah. Who's feeling a bit weird right now by this picture? Yeah. I love this. It's back to the old days. But this shows a little bit the setup. So we have these big talks in the beginning of the week, and during the week itself, you have participants. They present what they're doing. Because there's a lot, we have to split them up into groups, and we have the coaches join. It's a bit of a mess, but the idea is that we get their background, we understand what they want, and then we do sort of a matchmaking process to see who gets to match up with who. We then redistribute these groups based on interest, and then we sort of try to figure out what people want to do. The idea is that they bring their knowledge, their interests, maybe something that's half formed already. They bring that to the table, and then other people can join with that discussion or that idea, and then sort of take it further along. The best ideas in LAbO are things that come from ideas that are like half formed, or teams that people want to work on, instead of just a finished product that they just need to complete, or something that's not a LAbO team. And then what we can do is that we are with these coaches, we're trying to figure out who matches best with the students. at that specific point, it's not during the whole week that you always get to see the same coach. It's more like, okay, what do we think at that point that you need? So we might come with one coach or two coaches at the same time, sort of have these discussions with people, make sure that to provide the necessary guidance you need or we think you need. Sometimes that's really technical guidance. There's always a bunch of technical people involved in sort of building things as well. Sometimes it's more from a choreography standpoint or a performance standpoint, or looking at the space itself where people are in. And because the coaches are so interdisciplinary, you get a really nice mix of the kind of feedback that you get into. We also try to provide a good balance in skills and then gender and backgrounds as well. What's also important is that you can use all the spaces within the single, which is this big art center. They have all these spaces, and I'll show you in a bit where that is. So this is the kind of coaching we do, where you have a bunch of coaches all coming together. Sometimes you have these multiple sit-throughs. This is more at the end, where we do like a run through of the show, so we can give feedback of the project itself. Everybody's masked, so this was from last year. This is more normal. This is Angelique is there actually. So we organize these warm-up sessions as well in the morning, which is really nice, so that people can connect with themselves, with their body, with the space, with each other. That's a really important moment where people get together. We asked students to do it this year as well, and they wanted to, but they also wanted to do something else. They're like, okay, this is nice, but we basically want to do a rave, we want to dance. So we had the people from the single organize that as well, and we just did a rave. Every morning from 9 to 10, they were just going crazy in the space as well. And maybe it's a bit silly to show this, but it's just to show that they just set up everything. So if we ask them to do, okay, let's do a rave, they're like, okay, sure, we're game, we'll do this. We're organizing a rave. Make sure that the lights are there, that there's good music installation. Bring your own records, and then we can play stuff. That's kind of the atmosphere, this can-do atmosphere that's really useful in LAbO, I think. And also for a lot of students, having access to all that material and all the facilities and all just people and expertise is really, really useful. We also organize workshops and lectures. This is a workshop from Jennifer Torrance, who's actually a drum player. She's talking about her work. It's kind of weird that there's a person below the table, but that is Aurélie, and Jennifer asked Aurélie specifically to intrude during her performance, to introduce some chaos into the mix. This was without telling the audience that this was actually a thing. So she was actually given instructions or half instructions to sort of intrude during the performance. I would go crazy if this would happen to me, but Jennifer just embraces chaos. So yeah, sit down. So the workshops are often interactive. We did a workshop together with I did a workshop together with Tuur Marinus last year called Scores and Codes, about different ways that dances are scored or written down, because it's not easy to write down dance or create notation for dance. And then I did parallels with how that works in graphic design, where you're trying to communicate to people also what kind of score or what kind of code you would use to indicate these things. And then we performed this piece, which is 1 minute sculptures by Erwin Burm, which is this little score where people place these objects between themselves and then they stand still, and then that's like a freeze frame. They can make these sculptures, so that's just really nice. Yeah. So we have interactive parts. We actually, Aurélie did a workshop where we went outside and we recorded the sound of the city, and then used these sounds as a sort of impromptu performance. So that's all, that can all be part of it. This is another 3D scanning sessions we did with Madina. Not so COVID safe maybe, but yeah. We all got tested during the week a couple of times. So. And then what happens is, after we've done this super intensive week, the result is Parkour, which is on Sunday, where you have these guided walks through the building of people coming in, and they bring you into contact with the work, the people who have made it. And so you go through this list. Some of them are timed, some of them are more like open performances where you can come in whenever. And then some are really like, okay, this has a beginning, a specific beginning and an ending, so you can come there. Everything from music, meditative performances, dance, interactive installations. This is a game that was made actually by students from Concordia, or they were part of it. I think the girl in black there in the back, Emily, right? They created a game which is called Tardigrade Stage, this perfect virtual world that you could design yourself, and then it would take you into this other space. And then at the end, there was this insane paper monster that was created, and that sort of ate all of these. It was made of woven paper, also by a student of yours. Yeah, it's just completely insane. He's knitting with paper. And then it ate the hostesses of the show as well. Yeah, that's kind of nice. You never know what to expect. It's really weird. They can use, as I said, the whole building, so including the stairs outside here, which is also a very nice performance. People were actually inside, but they would see the performance outside. They would sort of roll down the stairs. It looked very painful. The hallways they could use. This was a great piece by Klaas, who had this completely insane personality built up, and just all this whole, yeah, I don't know how you call it, like for a wedding gown. Yeah. So yeah, I was all behind him. Oh wait, the pool they would use, the artworks in the pool. This is a dance performance. By Eric, we can see here, and Gizem. And I think that's really the key here, is that we are trying to start these unlikely collaborations between all these different disciplines, having musicians work with dancers, composers, word artists, graphic designers, tech media people, and sort of expanding your horizon as a young artist. There's also the case that not everything works. I mean, at some point it can also fail. Failure is definitely an option, because it's a pressure to put on the show for Sunday night, and it doesn't work well for everybody. So we had this group called the Trashy Group, and they got sort of lost in this merry-go-round of different ideas that they wanted to do, and this hectic schedule. And what they did is they basically had this idea at some point of, okay, our project has failed, we can't make anything. But what they did then is made a super interesting reflection on how they failed. So the thing itself was like a written text explaining how failure happened in this work itself, and that was actually part of the work. And the installation itself was also really well put together. So you have this setup, and then you could read the text, but if you got too close, it would also fail. So the projection would drop out, and you wouldn't be able to read it. It would crash or seem to crash. So that was also part of it. And so it's super intensive, overwhelming pond of creativity, people coming from all disciplines, having the freedom to explore, fail, create. The reason why I'm telling you this is because we're making a new edition called LAbO 2020. The team is outside, and I think from the park there's people actually getting sent there. So there's like an invitation for people to come and join us. I want to talk briefly about the team, because it's something that we came up with while we're doing LAbO. It's like everything's happening in the building, but I sort of found this team of inside and outside super interesting. So the idea of how we present ourselves from as outside is not really how we really are, and what does that even mean when we really are. So think about how we are controlled by algorithms on one side, but then also have to present like a public face on social media, on Instagram. This mask that we do. We also had this discussion about the metaverse, for example, where you have like your representation as an avatar, which is completely disconnected from this physical body that you have, and like it's very different from what you want. But it's also the outside as a place to wander aimlessly, to give yourself some freedom to explore, to contemplate. It's also, of course, this idea of the inside and the outside, the barriers, the walls separating people, cultures, the outsider, the refugee, newcomers, that kind of team. And whenever we use this word, there has so many meanings to it, and all of these meanings are welcome in this discussion around what LAbO 2020 could be, or the kind of things that we want to bring. So that's the theme that we want to explore. Yeah, let's go outside, in this case, outside of Canada, because it's in Belgium. So that's a little bit of what LAbO is about. I also want to talk about the importance of technology and then sort of get into the AI part as well. Technology has always played an important role in LAbO. It's kind of the key discerning factor, I think. And sometimes that's decidedly low tech. This project, like called intertwining, is basically these huge elastic bands stretch out into this space, which is 6 meters high. And they created this enormous construction, and they took these little contact microphones, attached them to it, and you can play like a snare instrument. So you could touch these, and they were super, super sensitive. So every little sound you make, or even walking through the room, would actually vibrate the strings and would play this this huge instrument. And they added other instruments like the piano, guitar. There was a dancer in the middle dancing. So it's a beautiful piece. Space Game, also from 2019, was this continuous performance where participants could walk through this construction of canvases with lights and interactive projections with a Kinect depth camera that actually tracked the bodies in space and then projected new shapes on these canvases. We had a dancer from LaSalle College, which is in Singapore, who were also joining then. And she challenged the audience to dance with her sort of by mirroring their movement. So as people were walking around, she would sort of walk with them and move in the same space, which is super interesting. This is a student of mine, Michelle Maas, who was doing a master project about creating a digital relaxation space for children. This is actually in St. Lucas in our school. And she took that same setup, and then she created, together with other people, a digital seance. So like a place where they could call for ghosts. And it was created, you see this ring in the middle, which is like a electromagnetic conductive ring where you would be attached to, and it would sense the little touches or anything that you would do, little interactions with the space, and that would control the seance itself. It would control the experience, guided through their storyline of things that they had created as well. And then we get a little bit into the AI part. So this is a work by one of our former graphic design students, Jude Tuama, and it's called 100 Days. And actually the work itself started before LAbO, as I said before. That's what people bring. So she created 100 drawings of a specific place in Damascus, where she's from, that she had in her memory as a child. And every day for 100 days, she drew this place from memory. And every day you would get these little pictures, resulting in these pictures here at the top. And then we fed those into the AI software, and we created this new image row at the bottom, which is sort of the AI trying to recreate that. It's kind of easy because it's very similar every time, but then she created these digital destructions of the image, trying to destroy the image in Photoshop, taking these images, crumbling them up and then scanning them, or taking a picture of their phone where it's distorted and things like that. And then asking the AI if it could reconstruct these original images from these destroyed images. And the result was this, the result was this video series, which is not moving. Oh, there it is. Where you can actually see the AI sort of trying to reconstruct the original image and sort of getting this memory of or trying to reconstruct this memory of the place. If we talk about the algorithmic gaze, I think it's a good example of trying to understand what the AI is seeing as it goes through these images. And this was also created with software that we developed. So tomorrow we're talking about Figment, but there's actually software before that called Candelf, which allowed you to train these neural networks and then create these images from there. And that brings us back to the cyber sensuality project. So give you a brief explanation of the project, and I'll show you a video of the performance, and then I'll go into detail about its creation, because I think looking back behind the curtain a little bit is super interesting also for today. So this is the text, I'll read it. So after training the AI on our different gendered bodies and private intuitive acts, it eventually responded with its forms of virtual sensuality through gesture, movement, and sound. A gender fluid avatar emerges. With this, we not only question the power and understanding of our erotic movements inside of an algorithm, but also how eroticism is gendered. So this idea of eroticism was actually the start of their project. Like, can an AI be erotic? So can the AI perceive subtle signs of arousal to understand our displays of embodiment? Suggestive glimpses and subconscious human desires are translated into the virtual world. We present and simultaneously perform between the AI's interpretation of the erotic and the human, resulting in a flirtatious conversation with artificial intelligence. And I'll show you a video, but it's important to realize that the video itself is not shown as such. It's part of a bigger piece, but I can't show the recording because it doesn't really work in this space. You had to be there, is basically the thing. But I want to show you the video that was created, and then we'll go into the creation process, or at least a part of it. I think it's about 3 minutes. And it starts with black for a couple of seconds. And I hope the sound works. Sorry, I stopped it early. I don't want to show the full video. Maybe I should have, but the way that it works is that I want to talk a little bit about the idea there. Yeah, I'm a bit confused. I should have shown the full video, sorry. Yeah, again, it's shown in a different context where it's actually part of a bigger performance. Anyway, the idea. So what's the idea? What's the AI doing here? And the idea is really that it's creating a mapping between two things. That's what the AI that we're using is actually doing. It's creating a mapping between a real body and a virtual body. And the way that this works is there's this bunch of algorithms called an image-to-image translation system. So it takes in an input image and it takes out an output image. And then a machine learning system will learn that mapping between the input image and the output image. The idea is that these two images are what's called structurally similar, which means that they have to have properties of the image that are exactly the same. Otherwise, it doesn't work. If you take two completely random images together, it doesn't really work. But you can think of them as a different representation of the same image somehow. And this is a good example called de-oldify, which you've probably seen already, which can restore old images by colorizing them, by giving them color. And here, restoring is actually between quotes, because of course, the color information is lost when we got the original image. What it's doing is it's filling in this color information based on an understanding of the world that's machine learning has. But it might not be exactly the way that the color was set up, but it has some color that we consider correct, let's say. Now, how would you do that? How would you colorize these images? Well, the trick is that the mapping, so learning the mapping from a black and white image to a color image, is that we do the process in reverse. We give color images, and from those color images, we create black and white images. That's easy to do. We just desaturate all the images, and then we turn the process around. So then we ask the computer, okay, now if we give you a black and white image, what do you know about it, and how can you color it in? So that's what we're trying to do. That's the trick, right? This process is super, super flexible. So it works with color, but another process where it can do is this idea of filling in the blanks, where we basically take an input image, we crop out a square, we remove a square, and then we ask the computer to fill that in, to have some knowledge of the world and basically understand how it would fill that part in. Again, easy to create. We just add a random square somewhere in the image, and the algorithm needs to figure out what goes inside of the square, and then we turn it around and we can do it with new squares, basically asking the computer to fill that in. Another example is we take a drawing of a cat and then it produces a real cat. Now, to do that, again, we do the opposite process. We take all images of real cats and then we create this drawing filter. You can see this is a really weird way to draw a cat, but that's because it's actually a filter that looks like it's a drawing, but it's not really a drawing. But it works well enough. And so with this algorithm, it's super flexible. And we can do all kinds of algorithmic processes, which is what Figment is doing for us. And then from these algorithmic processes, we can create these mappings, and those mappings we can use to generate new images. For example, this, because whatever it's going to do, it only knows about a cat. So the whole world is a cat. Everything you draw is a cat, right? So you can draw whatever you want, and it's always going to come up with a cat. That's it. Like, it doesn't know anything outside of the cat world. So that's what it's going to create. And you can draw something that's definitely not a cat and will still do its best to turn it into a cat. So this algorithm, as you can see, is called pix-to-pix because it's an image-to-image translation filter. And this is the main algorithm that we use. So how does this help us in our dancer, AI dancer? Well, we also do a mapping, but we don't do a mapping from cats to drawings or to line drawings even. But what we do is we're using this system called pose detection. And pose detection is basically figuring out where each part of the body is in space. Actually in 3D space, but we only use 2D. So this is already a machine learning algorithm and that exists, that we learn how to do, that people have created first by hand and then trained with a machine to indicate where every part of this body is. And then we let the system learn how to convert these points, or these lines in this case, back to the original shape. If this sounds like it doesn't work, it's surprising that it actually does, because as you just saw, it clearly works in some way, at least. So what we do is we get a dancer, and this is also kind of the setup that we want to do today. And we have a dancer that dances and we extract their poses. In this case, what we do is we map them to two dots, just simple dots, where each point is. Importantly, what we do here, and this is an artistic choice, is something that we can choose to do, is we didn't actually label the points. So we didn't actually say what point is what. We didn't say this is a shoulder, this is the knee, this is whatever. So, and you can also see that in the video, the moment that somebody goes down on the floor, the system gets confused because it doesn't know which point is which. We don't tell it to. We basically handicap the system a little bit, so that it doesn't know how to treat that well and use that as a system. All right, so now we've created a mapping. And now what we can do is we can actually do the training. So we go the other way around. We say, okay, this is our image. And now what comes out of there? What do you create? And initially, as you can see, when we're training, this takes a while, a couple of hours. Initially, this is super rough. I mean, it's not even recognizable as a shape. It's just taking these dots and then adding some noise to it. But pretty soon, it already improves. As you can see here, this is after 2 generations or something. You can still clearly see the dots, but you can see that there's some form of the shape that comes here. And of course, the more uniform your data set is, the more dancers coordinate their the way that they are in the space, the way that they're dressed, for example, the more it can figure out what it needs to do, and the more homogeneous it's going to look. So we did a couple of tests with that during LAbO, and then first it was just randomly people doing whatever they were wearing, and then later on we started coordinating a little bit. That's also why in the video you can sometimes see that the AI gets longer pants and shorter pants, because that was what people were wearing, and it sort of seems to undress people, which is kind of weird. And then it quickly improves. So I think this is a video of the training where you can actually see the improvements in the shape as it's learning and getting better and better and better at the learning. What's really interesting to me, at least, is that it's inventing these pants, right? It doesn't know about pants. Remember, these are just dots in space. It doesn't know that these dots should be wearing pants, but it's still doing that because that's the only thing that it knows. It knows about these pants and not other pants. And this takes a couple of hours to train. And then once we have that result, you basically have 2 options that you can do. So you can feed the system back on itself, which means you take the input video that you used for training, you run it through again. And what happens is that the image gets distorted, but because the system knows what the image is, it actually becomes quite recognizable. So this is the image where you actually see that. You actually recognize the dancer that we saw a couple of slides before. Because the AI knows, okay, it's this height, so it's probably that person. I know this person because I know where the specific dots are located, and so it has to be that person. That's the first image you saw. The other option, which is resulting in these weirder images, is to do these holdouts, what we call, is holding out some basic data, basically leaving some data for the AI not to see, and to use that to input new positions of a new dancer that the AI has never seen. And that makes the results more weird and unpredictable. So specifically in our case, we had a couple of women dancing traditionally a little bit bigger than a man, and then we had a bigger man, and we have a girl who was sort of in the middle between that, so a large woman. And the AI was like super confused. So that's the result you see, because it doesn't know where to switch, and it constantly flips between the 2, which is what happened here. And then, of course, the way that the weird arm-like construction that happens here is because the dots don't actually, it doesn't know how to match up the dots with body pieces, and it's trying its best. Again, just as with the cat, it only knows about dance shapes. That's all its world. It knows nothing else. So it's going to create anything. It's going to try anyway, but it doesn't know how to do that well. So it's just going to invent new shapes. What this does, however, is make the AI very controllable, because you can feed it in new dancers, and it's that specific dance movement that you actually get. As I said, the performance, the way that I showed here with the video, is not actually how it was performed. We did perform it 2 times. So one is at LAbO, which I'll show in a minute, but the other one was like a projection like here, but then with a dancer in front. Now the dancer itself was actually the dancer doing the input. So she was actually dancing with herself, or an AI representation of herself. But the movement was exactly the way that she moved, because that's how it was recorded. And she said it was a really weird experience, because she had this really strange disembodied creature, but it still had the same movement vocabulary than she has, because it was her. So she would make these sudden movements, and the AI would do that as well, because that's what she was used to doing. That's how it was trained. Yeah, this is an image of doing that on the big screen. Off to the left, you can see the machine that actually was producing the AI. I thought it was kind of funny that they were looking at the AI machine as well. And then the performance at LAbO was actually projected on a curtain itself. And that allowed the dancer to play with the video that was generated. So at some point, she actually stands behind the curtain and wraps herself inside of this curtain, sort of appropriating the body of the AI and becoming the AI. So it creates this fascinating AI-human hybrid shape. So it was really inventive, the way that she played with this video as well. And we also, because we now talked about bodies, but we also trained this on faces. So same principle, instead of, so we also did this mapping, but instead of using pose detection, we use face detection, which detects the features of the face. And it learns a mapping between a photo of the face and what's called a face mesh. So the little points of where your eyes are and your cheekbones and things like that. What we do here is we feed the people back into itself. So the same video into itself. So the people are actually quite recognizable. You can tell who this is if you know her. And it also, again, produces the correct clothes for the person, which is also super weird because clothes are not part of the face mesh. It's just, this is the only part that it learns, but it works. But because the face mesh is so detailed, it actually could be able to make these recognizable recreations of these images. All right, and that sounds maybe a little bit complicated. I don't know if the whole process, and it still is a little bit, unfortunately, but as I said, for part of the research, that's what we're trying to do, is trying to simplify this process and democratize it so more people can use it and understand it. As I said before, the most important part for us is really not just using what's out there as is, like off-the-shelf stuff, but doing controllable AI, understanding what it's trying to do, letting it learn itself, and sort of that also avoids this idea of bias where the AI is producing things that maybe you don't want to know or see, because you feed in, you're responsible for the data set that you feed in. So it's up to you to decide, okay, these parts go in and these parts don't. And so the software that we created for that is called Figment. We're in the process of open sourcing this right now. You can already download it, but it's not open source yet, but we're working on that. There's a legal stuff we have to figure out. And with this software, we do the step before the training. So the training is still a little bit hard, but what we can do is we can prepare the data. So for example, what we can do here is we can use pose detection or this face meshing that I talked about, or a number of other techniques, converting it to line drawings. So all of these things that Pix2Pix needs, and then create this output images or series of images, like thousands and thousands of images that you can just then feed to Pix2Pix to actually feed into the AI. So it has a bunch of these algorithms built in to allow it to detect poses, to draw these things, to segment people out of the background, to detect faces. And because it's open, you can also make your own nodes and introduce your own machine learning models if you want to, which of course is a bit more complex, but again, this is still an ongoing process. But these output images can then be taken in batch and then used as input data for an algorithm like Pix2Pix. So after LAbO, we actually had a bunch of offspring. So the AI actually created more AI because two of the participants of LAbO actually continued working on not necessarily the AI itself, but just the team that they were exploring. Again, people bring in these teams because that's what they really want to work on. So it's logical that they still keep that process going. The first one that I want to talk about is Cycle Gender, or this project by Madina called Gender Fluidity. She's a BA student at the Warsaw School of Arts, and she came to LAbO in the summer, but she's now an exchange student at our school in St. Lucas in Antwerp. Again, this is all very early, but I wanted to, I asked her if I could show it, and she said, okay. But her work was looking at ways in which computers understand gender and the fluidity of gender. So that's what her research is about. And we wanted a way for the system to sort of explore this, how you would say, axis of gender fluidity, where everybody sort of fits in a different place on this gender scale, line, network, web, whatever. And it was kind of funny because I was like, okay, that's cool. We can do that. We can switch genders and play around with that. So make a folder called female and male. And she was like, what? This is completely against the whole idea of gender fluidity, is making two distinct folders and say, okay, this is the only thing the computer has. But yeah, that's the and I think that's sort of the interesting part. Is also why I bring it up, is because of this discussion. It's all the algorithms actually are made this way, where there's a clear distinction between, okay, this goes in this category and this goes in that category. And this whole idea of fluidity is just not part of the algorithm at all. It doesn't know, it doesn't even care about the whole concept of gender fluidity. So you have to provide it in this form, and it's already super problematic in the beginning. That's also why we wanted to explore what came out. And then the results, again, super early. I'm not too happy with it, but they're also very typical. This is all from female to male, so people get beards. Here, what the problem is that the faces don't actually match up. So we give it female images, again, typical female images, typical male identifying people. And then what we let the computer do is through a different process, because they don't match up, right? There's not one-to-one. They don't have structurally similar features. Is we use a system called cycle again, which basically says, okay, go from female to male, then back to female again, and then see if those two still match up. That's what it's trying to do. So it's basically creating a cycle and trying to figure out if the cycle works. As I said, the results are not amazing, but it's yeah, we still have some work to do there. We're currently exploring a bit different options, but I wanted to show this anyway, because it shows how difficult it is for to tackle these topics, because the algorithms you can use are just very binary. They're really like, okay, classify this to me. And then the other one that I wanted to talk about is Maureen, and Maureen by Alexandra Fraser. She's a master student at St. Lucas doing the social political master, and she created an interview with an AI. So she used various text generators like GPT-3 to produce answers to her questions around a creation and how AIs can create or replace us as creators in the future. And specifically, she came to me to help her develop a face for Maureen, because it was just this voice, but without a face. And we used a similar system to the face mesh generation that I showed before. Only what we wanted to do is we wanted Maureen to really feel off. So instead of using real faces as an input training set, we used generated faces. So there's this website called This Face Does Not Exist, or This Person Does Not Exist, which are all fake faces. So all of these faces you see here are all generated already by AI, even though it's sometimes super hard to tell. Like if you would just glance at this, you wouldn't know. But there's one specific, the woman in the glasses is super scary actually, because she has her eyes open in a very weird way. Anyway, the one thing that you can tell is that the eyes are always at the same position and the mouths are always at the same position. So they're really normalized in that way. But it works really well. This is a really good input set, but because again, we wanted this Maureen person to be this AI. This is actually, you could think of Maureen as sort of a second generation AI, which is an AI that's already trained on the results of another AI. So it's not a new one, it's already an offspring of the existing one. So we take these and then we generate these face masks. So this is the mesh you see. As you can see, it's super detailed. Again, the eyes are at the same position, but sometimes the head is rotated. And then here you can see a very early Maureen talking about her work as an artist. And I'll show the audio as well.
Can you describe your appearance? I like to picture who I'm talking to. I can't possibly have an appearance. Do you see yourself as an artist? I do, but I'm not quite clear what the hell I'm doing there. I love to know how artists get inspired. Who's your favourite artist? I'm always inspired by how much I'm able to do and learn from people who have worked on my work. I was inspired by my work, my life, my music, the way I've chosen to express myself through music, the way I write, the way I write art, and how I keep telling myself stories.
Oh. Yeah. So you see the AI is super egocentric, only talking about itself, only inspired by my own thing. And of course, it's all appropriated because it's an AI. It's all required to learn from data. So it's super interesting that the GPT-3, the text generator, is actually talking about, oh, it's all my stuff. I own this. But but it gives a glimpse into the mindset of what we're doing. And I think the images are actually quite beautiful already, even though they're not perfectly aligned yet. I also want to talk a little bit outside of the what we did and talk a little bit about some inspiration that we have. Briefly, the work of Scott Eaton, who you might be familiar with, is also a photographer and then gives drawing classes as well. But through his work, he actually created lots of professional photography, and I used AI to turn that into these different shaped bodies, in this case, these rounded bodies, as you can see here. It's really interesting. You should look up his work. So that's Scott Eaton. And then another one I think is interesting is Mario Kligeman, who is did this a bunch of projects, also mostly with faces, because that's something we react to. And again, the face data is there. There's a lot of good pictures that we can use, and his work is also very, very beautiful. And that's what I have. So I hope this talk gave you some inspiration, and I want to open it up for questions.